section. So basically, this has to do with all the applications that has to do with self-driving cars. We have your application that were created with reinforcement learning. We have application created with the GAN algorithm, which we spoke about when we talk about machine learning. All right. So now looking at some different technologies that we spoke about, for those who did not attend last week classes, please go back to the recordings and yeah, go back to the recordings because we kind of summarized and went back to machine learning and yeah, kind of have a quick run through the materials. So please watch last week's videos. That will really help, especially if you're preparing for your mock exam. Refresh this page. Okay. Second, I'm just refreshing this page. I think it's kind of frozen. It's not getting the full screen. Wonder why the whole browser is frozen here. What's happening? Okay, let me see this. All right, so okay, I think this should work now. All right, so the objective of this part of our course material is just to make sure we understand all the concepts and application of RL, reinforcement learning, and we have an understanding of GAN and understand knowledge graph and intelligent driving. So intelligent driving is basically all your self-driving cars, your you know, autonomous driving. Can anybody give us a definition of what is reinforcement learning in your understanding? What is reinforcement in your understanding? What is reinforcement learning in your understanding, in your own words?
I think reinforcement learning is I don't know if I should say teaching a machine whitelist. You either give it a reward or you punish it, something along those lines.
Yes, yes. Yeah, you're right. Anybody else wanna try and give us your definition of reinforcement learning? Anyone else want to give us a definition of reinforcement learning? Anyone else? Guys, this should be easy. I'm sure you've heard reinforcement learning many times. Like we spoke about it. What is reinforcement learning?
It's a machine that learns from its mistakes.
Yes, that is also a definition. All right, so basically, reinforcement learning is just a type of machine learning. So a type of teaching the machine how to understand about certain tasks, how to learn from data, and be able to perform a certain task. When you're creating an AI tool and you create it by using a way of punishing or rewarding the machine. So basically, we put the machine in an environment, it takes certain actions, and those actions give a result to either a reward or a punishment, depending on how the machine is going to, depending on the choices that the machine is going to make or the actions that the machine is going to make. So that is reinforcement learning. All right. So we're going to talk about reinforcement learning. We're going to talk about GAN. The GAN is just an algorithm that is used more for image generation, you know, all these images that you see on social media and everywhere where people are creating fake images and all those things. Those are created with a GAN algorithm. And then we have knowledge graph. Knowledge graph is basically a way, like a method or a technology of creating, connecting, creating a relationship between certain data with certain attributes. For example, if I say Jacob Zuma, so in your mind is already thinking of someone who was a president called Jacob Zuma. Even if your neighbor name is also Jacob Zuma, but you wouldn't really think about your neighbor. You're thinking of a president called Jacob Zuma. You will think of a few things about him. So the fact that your brain connects to all those information, that is basically a technology created there. We can create a technology based on the way the brain can also work, and we call it knowledge graph. This is what you find, for example, in your search engine on Google. When you type something, Google can give you all those information. Yeah, so that knowledge graph. And then we have intelligent driving. So intelligent driving has to do with self-driving cars. Okay, so we have autonomous driving. All right. So thinking of reinforcement learning as we define it, it's just a branch of machine learning that will emphasize on how the machine is being trained. So the machine is being trained by placing an agent in a certain environment in order to maximize the expected benefit, which we're going to call the reward. So, for example, if you have the agent, right? So the environment is, for example, the world here. So when we're talking about a self-driving car, so we're going to create an agent, right? So this agent is going to take actions. So it gets to a place. This is the state which is the robot. Maybe the robot is red. So this agent is going to take an action. So you set the rewards. So if the robot stop here, it's going to earn maybe plus 6 points. But if it doesn't stop, if the car doesn't stop, it's going to lose 6 points. So now every time the agent is learning in this environment, if it take a wrong decision, it's going to accumulate a punishment. If it take a right decision, it's going to accumulate a reward. So the agent is going to be taking actions. If it's make a mistake, the next time it comes there, it takes the action that will give it a reward. And the more the agent is taking decision that give it reward. It's learning from this environment and it's learned to do the right thing. So this is how you get to a point where you've created a um, good model. All right. So basically, when we talk about this cutting edge AI application, we actually focusing on the most advanced and innovative applications, as this example here. So most of these advanced AI tools are created using reinforcement learning. So you have all these robots, self-driving cars, you see. So these applications usually combine, like you have your deep learning, your big data. So we need a lot of data, you know. We need high performance computing. Remember last time we spoke about all these servers. So we need high performance computing, and we need to have a strong understanding of what we are actually doing. All right. So when we're talking about these generative AI that you see all over the internet nowadays that are creating new content like text, your images, music, videos. Nowadays, you can create a video just by writing a prompt. You describe the video, and then you have AI tools that can create all these videos for you. You can create text. You can tell ChatGPT to write for you an email, and all these things are created by this generative AI. You know, so example of generative AIs, you have things like ChatGPT, you have your Synthesia that creates AI avatar, you have your DeepSeek, you have your Gemini. All right. So now with autonomous vehicles, we have robotics. So these are trained with reinforcement learning. These systems are trained with reinforcement learning technologies. So we use them in cases such as the transportation, in healthcare, in all the warehouse where you can have robots that are actually working there, in the military. All right. So, and this is a very advanced technology, and there is a strong future in reinforcement learning because the whole world is thinking of how can we automate everything, right? Of course, the whole world is more focused on what we see on social media, which is more about generative AI. AI just to show us pictures, but that is a level of just entertainment. But when we're looking at the real deal is behind reinforcement learning, where we're going to have self-driving cars, where we have all these robots that are going to be used in different industries, So you'll have countries that when you go to war with them, there will be no soldiers, so there will be no casualties. It's all robots. You're fighting against robots, So that becomes a different type of world, right? So if we look, for example, in the healthcare system, when we have healthcare AIs that can help us to diagnose diseases, to design all the drugs being used in the hospital, and to actually personalize treatment based on the type of patients that they have in the hospital. So this is an example can be when, for example, AI can look at all the images of the scan that are done on cancer patient, for example, and the AI can actually personalize the treatment. The AI can actually suggest how the person can be treated. It can personalize the medication of the person. It can help with faster diagnosis, in a sense. So AI can really be used in many areas. So we have now, since COVID, we have a culture of online education, right? So how do we have, I'm sure many of us have been in a situation where you meet someone in class. It's not that the person is not that smart, but because the person grew up in an area where they were not exposed to English that much. So now when they get to university, they are challenged by the language, not by the content of the material. So now you find the person who is being challenged by the language. But now, how about if we have AI in education, where a lecturer or a teacher can be speaking English but in different part of the country where people have a challenge, or not even in different part of the country, even in the same class, where students who have a challenge with the language can actually hear what the teacher is saying in their own language, so that will help with more understanding and making sure that if you are, for example, in a country with 11 official language, 11 official languages, people can be strong in different areas in different languages, and that will really be good. And that is achieved with AI. So as we implement all these AI technologies in different areas, it's actually works well. So when you look at, for example, you look at your GPS, right? You look at your GPS, you're trying to hear how your GPS is pronouncing African names. You can see that there is an issue there in terms of training this AI to understand the pronunciation of word. If you're driving in a street of China today, you're using a GPS in China, every word is pronounced properly. But if you use a GPS in South Africa and it's taking you to a certain road, and the name of that road is an African name, you can see how the pronunciation is not correct, right? Why? Because that's the GPS has not learned how to pronounce those. So empowering AI tools with African data will make AI works well in Africa, or else it's going to be a challenge, because we're going to have these self-driving cars that have where you have to actually give a voice command, but the algorithm of the natural language processing behind that AI was not trained with the African accent, for example. Or let's say, for example, you not even the language, you have certain words that are only found in South Africa. For example, if you go out of South Africa and you're talking about turning left at the robot, people will be looking for a robot that look like this one. They won't understand what are you talking about. But you were talking about this. This is pure South Africa, calling it a robot. When you go to other English countries, they will call it a traffic light. So that's the thing. But if an AI tool is not trained with South African data, it will not understand a term robots can also mean traffic light. All right. So those are certain issues when it comes to AI. It also depends on the type of data we're trained. So when we're creating a reinforcement learning algorithm, we will look at two objects, the agent and the environment. All right. So we look at the agent and we look at the environment. And the agent is actually what we call the learner. So the agent, excuse me, so the agent will be the learner. So the agent is the one that is going to learn from this data. So the agent is going to be the decision maker. So the agent is going to be making decision. So the agent will interact with the environment and it's going to choose actions. It's going to choose actions and learn from the policy. So a policy, when we talk about the policy, obviously we're talking about the rules. So there is rules that are set, right? So the environment will actually be everything outside the agent that the agent will interact with. So if in this environment, we're going to have something that we call a state, which is the situation in which we are. And then the feedback that we're going to get from the action that the agency is going to take is what we're going to call the reward. So we have the agents that will take an action, and then we're going to have a policy, which means that this policy is the rule that this agent needs to respect while it's taking these actions. And then we're going to have a reward, which the environment is going to provide to this agent based on the current action. And then we're going to return, obviously, the feedback that we have based on the reward that we're getting. So every action will give us a reward. So an example that I can give you, you're creating a robot that needs to go from, this is the starting point. And then you have, this is the end. You want this robot to go here. You want it to go and fetch something here. So now, what we do, what you do now is that you have, let's say you have, this is the path there. This is kind of a wall. So this robot will go maybe take one step left, and then it hits the wall. So it loses -1 as the punishment for that. All right. And then it's going to lose that -1 here, and then you take another action. This is a second step. At this first step, it lose 1, and then it goes here. It keep going in this direction. It gets here, it lose another point, and then it goes here. From this that step here, it gain a point because it's never hit a wall, and then it goes here, it loses a point. So in the end, by the time it reach here, it has lost, maybe we have a -3, which is the sum of reward. So we have -3, and then it restarts again. So if you say you need to train it 1,000 times, so it's gonna do it 1,000 times. So the second time when it goes here instead of going up there. So the second time, let me just change the color so you see that. So the second time, the first action it's going to take, it goes straight, and then it's going to get 1 point. Then it goes straight again, it gets another point, and then maybe it goes here, it lose a point, and then it goes there, it gain a point. So the final reward in this case will be +3. And then it's gonna restart again. So if you ask for the agent to train 1,000 times, so after 1,000 times, it's gonna see which actions has accumulated more reward, and that is the action. So in this case, for example, maybe the action was gonna be to go the 4 steps to take it forward, and the 4 step forward has given us maybe a accumulated reward of +4. So this will be recorded as the model. So this will be what the AI is going to do. So next time the robot is there, the robot will look at what it needs to get. It's gonna go straight. It's not gonna go left and right because it knows you have to go straight. That's the correct action. Okay, so that's how reinforcement learning works. All right. Any questions so far? Okay, so you need to understand that the way reinforcement learning works. So the action that we take. So the action, for you to understand what is the action, understand what the agent can do at a given time. So in this case, I was showing you at this time, it goes left. At this time, so it needs to recall the time. So at a given time, what is the agent doing? An example can be in a game of chess, moving a piece left or right or in the next box. That can be an action. And the policy is the strategy or the rule that the agent need to follow when it's choosing action. In this case, it needs to go as much as it can go. It must not touch the wall. So that's the policy here. Okay. So the policy will be kind of a map that will map the states where we are now and the action that we're taking. So in a self-driving car example, the policy will be if an obstacle is detected, the car needs to slow down. If there is a red light, the car needs to stop. That can be your policy. So now the reward will just be the signal from the environment to tell the agents that you've taken a good or a bad decision. So, for example, if you're creating a robot that will work as a vacuum cleaner, so if it's able to clean dust, it will get a reward, a +1 reward. But if it's bump into the wall, it gets a -1 reward, which is a punishment. Okay, so when the total accumulated reward over time will help the learner, which is the agent, to learn what is the right action. So when you look at this, for example, here, how many states do we have here? Can anybody tell us how many states we have in this case? How many times are we checking the state of the robot, of our agent, in the example I gave you? Can anybody tell us? How many actions are we taking here? Anyone? How many actions are we taking there? Anyone can unmute yourself? According to this explanation, how many actions, how many steps? So how many actions is our agent taking? All right, so yes, 4. Yes, that's perfect. In our cases, we have 4. So at each state, we record what we give a feedback. So basically now the total here is obviously what I said here. So we actually have the total reward, which we can represent as GT plus. So this will be the reward at time 1, right? RT, okay, time +1 step, plus the reward at time where we started, +2, you understand? So, and then +3, +4. So we have all the 4 steps, and that will be the total reward. So we have the reward. So basically, to just summarize that, how it works is that the agent will observe the environment state, it's take action according to the policy, and the environment will respond with a new state and the reward. Okay, so the agent will now update its policy to maximize the return over time, which return is the reward over time. Okay, so that's how this will work. So the algorithm, we will be classified. So we're basically going to classify reinforcement learning algorithm into 2 classes. We have a direct solution and an indirect solution, right? So that's how we're going to classify that. And it's classified based on the policy. Okay, so the classification is done based on the policy that we are using. What does it mean? It means that we can look from the environment, we look at the state, and directly we can read the policy, and then we take an action that will give us a reward. Or the indirect solution will be from the environment, we get the state where we are, but now we set certain values that we are trying to achieve, and then we take an action, and then we learn a policy. So a policy is learned from the action. So the direct solution, so the optimal policy function is optimized during the interaction with the environment. So as we interacting with the environment, we also getting the policy. But in indirect solution is that the type of this algorithm, what we're gonna have is that we're gonna indirectly calculate other indicators, and then we're gonna deduce the policy based on the results of these indicators. So we will first get other indicators, before we could even get the policy. So we don't get the policy directly. Okay, so that's the indirect solution. So basically, to just try and understand that when we're talking about the direct solution, so we're basically going uh, to kind of maximize the expected return, like to maximize how much reward we're going to get from this. So we're going to actually go straight from the environment. We optimize the policy based on the interaction with the environment directly. So there is no values that are set before. So the problem with this can be sometimes when you have less, you don't have a lot of samples to learn from, it becomes a problem. So you're gonna need a lot of samples for the machine to really learn perfectly. So we have some examples of algorithm that are used with direct solution. So you will hear they can tell you about algorithms such as the PPO. When you're doing some research in reinforcement learning, you can see when you're coding, say policy, you use a PPO policy. That is a proximal, proximal policy optimization. So that's one of the policies that you can use there for direct solution, right? Now, in terms of indirect solution, an example can be you have the Q learning. This is one of the algorithm that's Q learning. Yeah, Q learning that use the indirect solution. All right. So does anyone remember what is AlphaGo? Can anybody tell us what's AlphaGo?
The first AI to beat a human in a chess game.
No. Anybody remember what is AlphaGo? Anybody remember? The first AI that beat a human in a chess game.
Is it not
That
a
was
program that plays board games Go by means of web development?
sorry, come again?
Is it not a program that plays a board game Go in essence to web development?
Nope. Anybody else remember what is AlphaGo? By the way, for the first AI that beats a human at the chess game, can anybody tell us what was the name of that AI?
It was Deep Blue, sir.
Yes, that one was Deep Blue. Deep Blue. That beat Gary Kasparov. Deep Blue. That beat Gary Kasparov at the world champion of chess. Was beaten by Deep Blue. Right. AlphaGo is another reinforcement learning model that beats the Go player. Go is a game played usually in Asia, where you play, with like white and black circle. So they play it on a board. It's a very, very intelligent type of game. And AlphaGo in 2016, AlphaGo was able to beat the world champion, Lee Sedol. Lee Sedol was beaten by AlphaGo in 2016, and the score was like 4-1. So when AlphaGo was trained to play this game of Go, so the action that AlphaGo take is where to place the goal. So where to place this, if it has to move this to whatever move. So it's learn that and then check what's the situation here, who's winning. So now it's playing against itself. So if I'm not mistaken, I think AlphaGo has to play 1,000 times against itself. So if it's losing, so we're gonna get the status at each action that we take. We get the status. Okay, we've moved at a certain place. What's the reward? If it's losing, we have a -1. If it's winning, we have a +1. And then the environment send this feedback to the agent. Now we have a state. The new state, take another action until it has played like 1,000 times and find ways of winning. That's how it was able to beat the world champion. That's how reinforcement learning will work. All right, so you can create your own agent. It's very easy nowadays. There's many tools that can help you create your own agent depending on what idea you have and how you want to do it. Okay, so the next one will be the GAN. Guys, you remember when we learned about machine learning, when we learned about deep learning and algorithm, we learned about the GAN, the generative adversarial network. So this is the neural network. This is the algorithm that help you with all the images that you're seeing nowadays, all these images that you see, fake images, or not even fake images, all the filters. If you are a woman, you always use filter on your TikTok, what's that, TikTok or Snapchat, all that they are using a GAN AI behind. And how is the GAN AI? How do you train a GAN AI? So to train a GAN AI, this is what we do. We take the right information. Let's say we're dealing with pictures. So we're going to provide the real pictures. So the way the GAN works, it has a generator and a discriminator. So generator, we call it G, and discriminator, we call it D. So what will happen is that the generator is going to generate fake images that look like the images that you provided. So let's say you provide a picture, your pictures are pictures of cats. So it's going to generate fake pictures of cats. And now the discriminator is gonna try and determine whether that images that was provided is real or fake. So every time you have an input, so you're gonna have you have the generator. So the generator will bring as an input, it's going to bring a fake image, and the discriminator will determine if this image is real or fake. And if the image was really fake, it's going to note that as a good action. If it's made a mistake, it's going to note that as a wrong action. So as the more it's generating that, the more it's discriminating that, it's learning from how does a real image look like, right? So this type of technology is used in scenarios such as image generation, text generation, speech enhancement, and image super resolution. So you have, as the learning process is happening, so one of the inputs is the real image, and one of the inputs will be the fake image that was created by the generator, until it gets to a point where it understands how the real image should look like, right? So when you're looking at the, what you call this, when you're looking at this this GAN GAN application, you'll find it in, as I said, in social media and that. So basically, what you need to know that is that the GAN is just a type of neural network that has two parts. The two parts are um, the generator and the discriminator. What is the generator? The generator would generate fake data that looks like real data. So that can be images, text, sounds, Um, so, and then you're going to have the discriminator that will distinguish between the real images and the fake images, right? So the goal of the discriminator is to determine between the real images and the fake images. So the step one, generate fake images. Step two, the discriminator will look for the sample and predict if it's real or fake. Okay, so as it predicts if it's real or fake, that will help the discriminator to be trained to correctly classify real from fake. Okay, so the generator is trained to fool the discriminator, and the discriminator is trained to not be fooled by the generator. All right. So that's how it works. So this will obviously work in the scenario that we've mentioned here, image generation, converting images, text to image conversion, So that's exactly how you get to a point that today we have things like ChatGPT where you can actually write a text and it generates for you pictures and all those things because it has been trained using this algorithm. Okay, so you look at that, a scenario can be when you have trying to generate this image because this image was blocked by a picture, so the algorithm can easily be able to regenerate the rest of the image because it has been trained to understand how the real image should be, right? And the next will be the knowledge graph. As we said, the knowledge graph, what is knowledge graph? Is just think of it just like a structured, representation of any type of knowledge or any type of information in the form of we can talk about an entity, in the form of an entity, in the form of a certain relationship, right? In terms of a property concepts, right? So when we have an object that exists in the real world, there's many information about that object. The object can be a person. So when people talk about you, there's things that they remember about you. Maybe you are their colleague, or maybe your date of birth, your time. So if I'm looking at the knowledge graph and I want to take a certain information, a certain concept, right? Such as Albert Einstein. Albert Einstein. So if I talk about Albert Einstein, what do you guys think about? If I say Albert Einstein, who's Albert Einstein?
Scientist.
Yes, you see. So you think of a scientist. Someone else can say, okay, thinking about physics, thinking about his country, Germany. So someone else can remember. Okay, he was born maybe in a certain year, maybe I don't know, 1879 or something, or 18 something. So you think of all those information. That is the knowledge graph. So the same way, when you have knowledge about something, that's the way we actually create a technology. We take the same structure that we're going to represent in terms of computers, right? So we will take data that can be extracted from a certain database or a certain source, such as the internet or a certain website. So we're going to identify all the entities. That means that an object that exists in the world and can be distinguished from others. So the entities will mean that when we look at this object or this information. So we need to extract what's the source of this information, identify what's the link to other information, the relationship with other information. So we look at Albert Einstein. Okay, fine. He's a physicist that was born in Germany. We think of him as a scientist. He invented one, two, three. You understand? So that is how application will work together with the technology of knowledge graph. So this is used mostly in AI search, in business intelligence. You have it in your search engine, such as the Google search engine. So Google use knowledge graph to try and improve their search results with a lot of information. So when you search about something, they can actually bring you all this information, all these websites that can have that. You have it on Netflix. Netflix for them to recommend you certain movies. So they have to take certain knowledge about you, about your profile. What have you been watching? You understand? So they can manage what have you been watching, what type of movies do you like, what type of where you from. You understand? So if you open your Netflix and I open my Netflix, we're not seeing the same thing. We can be in the same house or anything, but we're not seeing the same thing. You understand? So you find it in systems such as Netflix, Amazon. You find it in all your question answering chat bot, where you can actually go on a certain website and answer to certain question. So you have the knowledge graph technologies being used there. It can also be used in terms of your frauds detection, where the bank can actually detect any activities based on analyzing the relationship between accounts, your account, and certain transactions that you are making. So the bank can automatically flag a certain bank account based on that. So that's how knowledge graph algorithm will work. Okay, so talking about the history of knowledge graph is the whole technology started a long time ago, since the 1950s, and then we even come to have the World Wide Web. Okay, so that's how you have your internet. You always have www, 3w dot whatever. So this is just to try and connect everything in one knowledge graph. Okay. Okay, so in the process of constructing a knowledge graph, the way it's gonna work is that the first step will be to determine the domain, which means that we want to determine where is the knowledge coming from. So we kind of define the scope or the purpose of this knowledge graph. Okay, so we need to find what area we're talking about. Is this if I tell you, for example, if I say James Bond, if I say James Bond, we find ourselves in what type of domain? We find ourselves in movies, for example. So this is a movie. So if you go on your search, on your Google search or your any search engine, you search for James Bond, it's already based on the information from different platforms. Okay, we're talking about movies. So the search engine now know, okay, we're talking about movies. It means whatever information comes next must be related to movies. So we're talking about movies, and then the next time will be understanding the domain. So we have a full understanding of the knowledge graph itself, and then we have to collect the data. So the data about whatever we're trying to search. So it collect the data, and then it's gonna extract all the information from those data. And then from there, we create a map in terms of everything that we've collected previously, and then we can create whatever application or use it in whatever application we are using it based on the relationship between those attributes, right? So an application scenario of knowledge graph, you can find it, for example, on your music application that can recommend you certain songs that you like. Why? Because you've been listening to certain songs. Now they start recommending you other songs because they have a certain knowledge about you. So it has created a knowledge graph about you. Okay, so you have the knowledge graph that is applied in other robots such as your Apple Siri. Okay, you have it on your Alexa. So Siri will learn from all the information that you have. You find it as well on your WhatsApp. The more you having conversation, it's learning from you. It's learning from how do you write certain things. Um, uh, how do you what you call this? How do you write certain words? How do you speak? The type of words you always use. The type of sentence. How do you make your sentence? So yeah. So that's how it's going to work. So that's how these AI tools will work with knowledge graph. Okay. All right. So any questions, guys? Any questions? Any questions? Any question, guys? Was everything clear? Is everything clear?
Yes, sir.
All right. All right, guys. So this is another example of the knowledge graph that is used in terms of oil and gas knowledge. So this is just to try and see how they can create certain pattern based on information that they have in this area as well. So yeah. So I think that will be all for today. Um, that will be all for today, and we're gonna pick it up tomorrow. So tomorrow we're gonna start with intelligent driving. All right,
Sorry,
guys.
sir, can I ask,
Okay.
when are we writing the mock test?
So we have 2 weeks. So we can start it from this week after we're done on Thursday. So you take your own time whenever you're ready. Remember, guys, you have to pass your mock to get an exam voucher. So don't rush into writing the mock exam. So we're gonna have like a week for that. So the other week, the week of uh, let me just check the calendar to see what's the dates next week. Next week Tuesday will be next week Tuesday will be 27. So next week we're not gonna have a class, so that will be the time for your mock exam. So on the Friday the 29th, yeah, so that's when we're gonna be expecting results. So I think the deadline, we're gonna take it Friday 29th, or what you call that, or latest Sunday the 31st. So before the first, so before midnight the first, we need to have all the results sent. Remember, when we talk about when we're talking about midnight, we're talking about China time. That means that it's gonna be after this side, so on the 31st. But I'll confirm that. But just note that next week we're not gonna have a class. It's